to America's favorite contest show. Are you smarter than a chemical engineer?
Woo!
Let's meet our contestants for tonight. First, from Houston, Texas, please welcome Aquiles Brinco.
Good night, everybody.
Now, from Torreón, Coahuila, everybody welcome Elsa Capunta.
Hi.
Now, from the beautiful town of Pito Real, Chihuahua, everyone welcome Mario Neta.
Hello, thanks for having me here tonight.
And last but not least, please give a warm welcome to our friend Este Bandido from Saskatoon, Saskatchewan.
Hi, everyone.
And as always, please welcome my dear friend and collaborator Inocencio, who is always helping us backstage. Chencho, how are you tonight?
Good night, everybody. As always, I'm really excited about today's competition. And what a wonderful group we got tonight.
You are absolutely right. Now, before we begin, let's remember the rules. You will face 5 consecutive rounds of questions regarding a topic not yet defined of science and engineering. The questions require you to give a detailed explanation about the phenomenon discussed. If you know the answer, hit on your table before everyone else and then you get to answer. If your answer is wrong, then another contestant can steal the points. Depending on how good your answer was, is the amount of points that will be awarded to you. The contestant with the most points at the end of the 5th round will gain the maximum prize of
$5,000.
I now have with me the Hat of Wonders. This mythical device will help us decide the topic for tonight's competition. And the topic is chemical equilibrium. So, without further ado, let's begin with question number 1. What is chemical equilibrium? And it's Mario! You get to answer this one, boy!
First, I will start mentioning that chemical equilibrium is a state of a reversible reaction, where the rate of the reversible reaction equals the rate of the forward reaction. Also, it's worth mentioning that the concentration in the products and in the reactants remains the same during the whole process. That's why it seems that there is no change being made during the whole reaction. That's why, obviously, we are in a steady state system.
Wow, that was a great answer, Mario! Chencho, please tell me how many points did he earn?
Okay.
That's wonderful.
He earned
thank you.
the great amount of
Thank you.
25 points.
Thank you.
And Mario goes for a very strong start, but nothing is decided yet. So that brings us to question number 2. What factors affect chemical equilibrium?
Okay. Cuando quieras, Picasso.
And this one goes to Aquiles. What's your answer, man?
Yeah, it's volume, pressure, and temperature, and
5 seconds or the points will be stolen.
okay, concentration. It's pressure, volume, temperature, and concentration.
And that's correct. Chencho, please.
No, that wasn't a very difficult question, and he almost lost it. 15 points.
What? Okay, easy there, champ. Look, I'm going to give you a second chance just because I think you're funny. So, if you want to earn the whole 25 points, explain what is happening in the following video. In the syringe, there is a mixture of 2 gases. Nitrogen dioxide, which is brown, and dinitrogen tetrodoxide, which is colorless. The syringe is sealed, so the gases do not escape. What just happened in the video?
That's easy. So, as I have already mentioned, one factor that affects chemical equilibrium is the pressure. Naturally, when the plunger of the stream is pushed, the pressure of the system increases. The mixture gets a darker brown inside because the concentration of the nitrogen dioxide increases. In order to try to restore the equilibrium, the system will make some nitrogen dioxide react and form dinitrogen tetraoxide, decreasing the pressure a little and changing the coloration to a lighter shade of brown. If the plunger is pulled, the pressure decreases, and now nitrogen dioxide is very dilute, so the reaction will happen backwards to produce more nitrogen dioxide and restore the equilibrium once more.
That was a good answer, man. So, tell me, Chencho, did Achilles hit the 25-point mark?
He certainly did. 25 points to you, Achilles. And now you are tied with Mario.
So, that brings us to question number 3. How does temperature affect equilibrium? And this one goes to Elsa. Give me a good answer, girl.
Sure. Oh well. When you increase the temperature, the equilibrium of the reaction will shift toward the endothermic direction. Inversely, when you decrease the temperature, the equilibrium of the reaction will shift towards the exothermic direction.
Excellent answer. Chencho, how much?
Wait, I'm not that yet. I would like to complement my answer with an example. If we have the reaction for the synthesis of ammonia, we can calculate how the equilibrium constant will change when the temperature does as well. So, wait a minute, here. So, assuming standard conditions, we have that the enthalpy, formation enthalpy for ammonia is equal to minus 46.19 kilojoule per mole, as hydrogen and nitrogen are homomolecular molecules. The enthalpy formation is going to be 0. So, as we are forming 2 moles of ammonia, the enthalpy change is going to be the answer is gonna be minus 92.38 kilojoules. So, as the sign is negative, we can see that the reaction is exothermic. So, an increase in the temperature will displace the reaction in favor of the reactants. This means that as the temperature increases, the equilibrium constant decreases. In this particular example, I think that is extremely important because it means that if we want to make the production more efficient as possible, we must work at high temperatures in order to make the reaction occur faster, and in high pressures in order to compensate for the lower equilibrium constant.
Amazing work, Elsa! Chencho, would you please?
Y luego, for her correct answer and very complete answer, the adorable Elsa gets 25 points.
What? Freaking what?
Question number 4. What is the mathematical model that represents chemical equilibrium and how it is interpreted? Well, this just became really interesting. Esteban, it's your turn.
Chemical equilibrium, it's represented with the letter K, and it's equal to the molar concentration of the product raised to the power of their stereochemistry coefficient divided by the molar concentration of the reactants raised to the power of the stoichiometric coefficients. The concentration given its molar, it's expressed in mole per liter. So if the K is a really small value, less than more or less like 0.001, we will have significantly more reactant species presented in the equilibrium. Likewise, if the K is really big, like really big, between these two values, then we have a significant concentration of both products and reactants in the equilibrium phase.
Excellent answer, Esteban. You really nailed this one. Don't you agree, Chencho?
Of course, sí, bla, bla, bla. La rompiste, hermano. Ganaste 25 puntos.
Oh, come on! This stupid game is rigged.
And so, with the 4 contestants tied with 25 points each, we finally reach the grand finale, the moment we've been all waiting for. Question number 5. And the last question is: describe a concrete example of chemical equilibrium in real life. Wow! Looks like you all are really excited for making it this far. Actually, you might be a little too much excited. Chencho, do you know who gets to answer this one?
Absolutely not. After reviewing the recording in slow motion, it seems that the first one hit was... Chan. Achilles.
Of course, I'm the winner.
Hey, not so fast, kiddo. You still have to answer my question.
Yes, an example, it can be blood. Yes. The red blood cells or erythrocytes contains a material called hemoglobin, which is a protein containing iron that is responsible for transporting oxygen through the body. Each hemoglobin molecule attaches to 4 molecules of oxygen, so the equilibrium conditions for the hemoglobin oxygen reaction can be expressed as an hemoglobin and 4 oxygens will give us a complex hemoglobin oxygen. As long as there is enough oxygen in the air, then a healthy equilibrium is maintained. That's my answer.
All right, that answer
Excuse me. That answer wasn't bad at all, but unfortunately, that's incomplete. You gave a very interesting example, but you failed to mention what happens when you are at high altitudes with a very limited amount of oxygen. So, at significant altitudes above sea level, the atmospheric pressure decreases, and in doing so, it is way much harder to obtain oxygen in order to survive. So, according to Le Chatelier's principle, which helps us to predict the changes in the chemical equilibrium, specifically in this case, tells us that the shift goes to the left, in other words, away from the oxygenated hemoglobin.
All right, you both speak with the truth, so I guess...
Wait, I want to participate too. What just Mario said is the reason why people need to use pressurized oxygen for a tank when they are not physically prepared, for high altitudes. The pressurized oxygen shifts the equilibrium back to the right direction of the reaction. However, for people born and raised in these conditions, their body can perform the equilibrium shift itself by producing more hemoglobin than normal.
Anything to add, Esteban?
Yes. Actually, I think it's in order to mention what happens when there is carbon monoxide poisoning. The carbon monoxide fools hemoglobin into think it's oxygen because it also bonds to the protein in groups of 4. The reaction occurs in an analogy way, except this time it produces a compound called carboxyl hemoglobin that not longer can be transport oxygen. It is also not reversible reaction because the bond between the carbon monoxide and the hemoglobin it's about 300 times stronger than the bond with oxygen. This causes the blood get darker, red tone, and cause symptoms like dizziness and headaches. To reverse this alteration, pure oxygen must be administered to the body so it reacts like the carboxy hemoglobin and produces properly oxygenated hemoglobin and the carbon dioxide, which will be eliminated through a normal exhalation.
Oh, nice.
All right. This has never happened before. All 4 contestants contributed to give a magistral answer. So, the only question remaining is, who is the winner of tonight's edition of Are You Smarter Than a Chemical Engineer? So, Chencho, would you please tell me?
It will be a pleasure. The winner of tonight's show is... Chan chan chan. Chan 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 chan. Chan 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 chan. Chan 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 chan.
And we're back! Chencho, who is tonight's winner?
The winner is... Well, I don't know. In my opinion, they already deserve the prize.
I absolutely agree with you, but we only have one prize, and you know, acting civil and sharing doesn't give a lot of rating, so we have to decide just one.
Well, it's gonna be a problem because for the first time in history, we all have final tie of all our contestants.
Oh, Dios.
All right, everyone remain calm. We can sort this out. I think the fairest procedure is to make it one final question. Whoever gets it right goes home with the final prize. Does everybody agree? Excellent! So we'll be having, for the first time in this show, a 6th question that decides everything. And the last question is...